All right, so the goal for today's lesson is to be able to solve system of equations word problems. And you can use any method for that. It's the word problem part that we're focusing on. So the hard part of that, I guess, is setting up the equations from your word problem. So that's translating verbal descriptions to mathematical sentences, looking for those signal words that tell you to add, subtract, multiply, divide. That you need to be able to do. It's just now, since it's a system of equations, there's at least 2 equations. Well, in this class, it's just 2 equations, but just no systems or 2 or more equations. So we're going to learn how to set that up. We're going to solve using any method we want, and then make sure that your answer answers the question that's asked. So instead of our answer just being a coordinate, it might represent like adult tickets and child tickets. So maybe the question's only asking for the price of the adult ticket, or maybe it's asking what the price would be if you got this many adult tickets and this many child tickets. You just have to read the problem and make sure you're answering the question asked. So not exactly a coordinate, but you know, you get the picture. So we have, well, I'm recording right now. I'll post it in the slides for later. But you also have some other videos that are helpful online. I only put one in there because that's pretty much the gist of it. But there's tons more out there. So if you need more examples, a simple YouTube search would suffice. Then you have your practice, which is a worksheet. You know which one's your practice because it says evens or odds on it. So make sure that you're doing the evens or the odds. I don't want you just to do the first 5. All right, I want you to get different types of problems asked to you. So they get different as you work down the page. But you only have to do evens or odds. The worksheet is on the back wall. I honestly don't know when I'll check it because I don't know if we'll have it done Monday. I really don't know. So just upload it to Schoology when you're finished. All right. I know I won't be checking it today, so that's for sure. But have it done as soon as possible and upload it to the link in Schoology. You also have an exit ticket today for yesterday's lesson, which was all about elimination. It's just 3 questions, so we'll save it for like the last 15 minutes of class. It might not take you that long. So when you do finish, work on your practice from today and check your answers on the back wall. The reason I put it toward the end is because since we're doing systems word problems, odds are we'll probably do a few elimination examples, so you'll get like that extra practice in before you take a little exit ticket on it. But any questions at all? All right, so then look at your note sheet. So system of equations, applications. It's like another word for word problem, all right, because we're applying it to the real world. Gives you a few steps to follow. So first, you're going to want to define your 2 variables. Variables represent what in a word problem? Your knowns or your unknowns? Your unknowns. Your unknowns. That's why we label them with a variable. So like if the question's asking for adult tickets and child tickets, maybe my variables will be A and C, right? Or if you want to just use X and Y, go ahead. But you need to figure out what represents what. So A would represent adult, C represents child. 2, write a system of equations using the given information. So how many equations are in a system? 2. It can be more, but in this class, it'll be 2 equations that you're setting up. Then you solve the system. You can do that using any of the methods that we learned. What are some methods we learned? Substitution, graphing, and elimination. Substitution, graphing, and elimination. And I'm not going to have room to write it, so I'm just going to repeat it. All right, whatever one you think would be easier. Sometimes it's easier just to substitute. Sometimes it's easier to do elimination. So just pick one and follow through with it. And make sure that your answer is relevant to the problem. All right, give exactly what the problem is asking for. If it wants adult tickets cost and child ticket cost, then make sure you have them clearly labeled. I don't know what else. So sometimes it only asks for one or the other. Just make sure you give exactly what it's asking for. Any questions about that? All right, so then let's start with number 1. We have the sum of two numbers is 30. So what does sum tell us to do? Good. And do we know what the two numbers are? No. So we can label them. What variables do you want to use? All right, X and Y. So X and Y, and then is 30. How do you write is 30? Good. All right, and then it says, and their difference is 12. So here's one equation. We still need to have another one. So their difference, what symbol is that? Good. And order does matter with subtraction. So we can do if X is the first number, X minus Y. And then is 12. So equals 12. Questions on how we made our equations? Does that make sense? All right, so that's really the hard part. When you get past this, then it's just solving using one of the methods we learned. Here's my system. What method do you think would work best with these? I agree. I think elimination would work best. Because do we have a common coefficient?
Yes.
Yes. Do you want to eliminate X or Y?
Y.
All right, if I want to eliminate Y, and you can choose to eliminate X, we're just going to eliminate Y this time. Do they have the same sign or opposite? So do I need to add or subtract? Good. Adding them together would eliminate the Y's. And because you had to do it to the Y's to get them to eliminate, you have to do it to everything else. So what's X plus X? And then 30 plus 12? And opposite of multiplying by 2 is? Good. And what does X equal? 21. So that's my first number, right? I still need to find the other number. And since this is a word problem, it's not necessarily saying like where they cross on a graph. We can just leave our answer like that. We can just circle it. So X being the first number equals 21. How do you find the second number? Good. Plug it back into one of the original equations. So I'll just pick the top equation. X plus Y equals 30, except now X is 21. And solve for Y. How do you get Y by itself? Think, how can I make this 21 0? Subtract. Good. So do that on each side, and Y equals 9. All right, good. So we have our two numbers, 21 and 9. And you can check it by plugging them both back in. Is 21 plus 9 30?
Yes.
Is 21 minus 9 12?
Yes.
So then we're good. Questions about that? All right, let's try one with a little more stuff going on in it. So let's look at number 3. We have the difference between two numbers is 9. So difference, what operation? Good. And do we know what the numbers are? So we can just do X and Y again. X minus Y is 9. Is means equals, right? So there's our first equation. Question about that? All right, so then the first number plus twice the other number is 27. If you're having trouble about where to start, I think starting with the totals works, because usually any totals are right next to equal signs, right? So is 27. And on the other side, it's the first number. What did we say is our first number? Plus, obviously a plus sign, right? And then twice the other number. So the other number is what?
Y.
And if it's twice that number, what operation? That so it should be 2y. That makes sense? Any questions? All right, so again, it's just those signal words. Now, what method do you want to use to solve it?
Elimination. Substitution.
Either one works. I did hear elimination first, but I think substitution would also work too. So it's just up to you. If you want to add y to each side, and then plug that in here, and then plug it back in and solve for y, go ahead. I like elimination, so we'll do elimination. Plus, you have a nice signal on elimination later, so we'll just get more practice in. So, do I have the common coefficient there, or do I need to make one? Good. On the x's, they both have a coefficient of 1. Do they have the same sign?
Yes.
So when it's the same sign, you good. So same sign, subtract. S. So what's x minus x? 0. And then don't forget, I had to subtract these here to eliminate. Make sure you do it to the rest of your problem. It's not just combining like terms. Because I have a negative y minus a 2y. What's that? Negative 3y. And then I have 9 minus 27. What's that? Positive or negative?
18.
It's 9 minus 27. Good. All right, now solve for y. How do you get y by itself? Good. And y equals negative 18 divided by negative 3. Positive 6. All right, I'm going to circle that. That's part of my answer. One of my numbers is 6. How can I find the other number? Good. Plug it into one of the original equations. So x minus y equals 9. X minus 6, because that's what y equals. And how do you get the x by itself? Good. We're going to add 6 to each side. And then we get x by itself. 9 plus 6 is 15. Good. All right, and check your answer if you wish. 15 minus 6 is 9. 15 plus 12, because that's what 2 times 6 is 27. So any questions about that? All right, I'm going to give you one to try, so I'm going to give you number 5 to try on your note sheet. All right, so number 5 is the you try. Have that one done. I'll project it in about a minute. And if you finish it early and you're just waiting on everyone, then start your practice. All right, but we're going to go over number 5 next. So if you did it correctly, no matter what way you went about it, whether you chose a substitute, graph, elimination, your answer should be 16 and 4 for the 2 numbers. All right, so I think making the equations is probably the harder part. So if it says the sum of 2 numbers is 20, do we know what those 2 numbers are before we start solving? No, so pick 2 variables. That's why we have x plus y equals 20. And then the difference, so subtraction, between 3 times the first number, all right, that one's pretty easy, so you know it's multiplication. 3 times the first number, which we said is x, minus, because again, the difference, twice the second number is 40, so equals 40. So questions on that setup? All right, and as you can see, this person decided to use elimination. So that's why she multiplied the first equation by 2, because she was trying to get a common coefficient. All right, it looks like she wanted to cancel out the y's by doing that. You could have chose to multiply the top equation by 3 if you wanted to cancel out the x's. All right, but she chose to cancel out the y's. So here's her new system after multiplying the top one by 2. All right, in this way you have to add to cancel out the y's, solve for x, plug it back in and solve for y. So any questions about that? All right, so let's look at another different type. So these are more like pretty simple translations. Let's look at more like real world problems. So back side of the page. Let's look at number 7 together. All right, so these are kind of like the ones that are on your test. That's why I chose this note sheet. So the cost of 3 boxes of envelopes and 4 boxes of notebook paper is $13.25. 2 boxes of envelopes and 6 boxes of notebook paper cost $17. Find the cost of each. So we're looking for the cost of what? So envelopes, we need to define our variables. What variables do you want to use for envelope? E, good, E for envelope. And then 4 boxes of notebook paper. So that's the other thing we want to find the cost of. Our unknown, what letter do you want to use for that? N or P, whatever you want. But first define your variables. Then we need to make our equation. So start with the first one. The cost of 3 boxes of envelopes. So what operation is implied when I have 3 boxes of envelopes? So 3e multiplication. We don't know what the envelopes cost, like the price per envelope, right? So 3e. And then 4 boxes of notebook paper. How would I write that? 4n. Right, anytime it's per box, each person, whatever it is, it's usually multiplication. And then the total is 13.25. The totals are usually next to what? Equal signs. So equals 13.25. Now, what operation goes in between these 2 terms? Good, because combined, that's what they cost, right? So combine these add. Questions about that? So that's one of the equations. The other equation we get from 2 boxes of envelopes. So how would you write that? Good. And then 6 boxes of notebook paper. How would you write that? Good. And again, combined, they cost 17. So we're going to add these together over here. And since that's what it equals, that's the total, equals 17. So that's the hard part, is setting it up. Questions? All right, if this was easy, then great. I hope you think it's easy on the test too. This is what it looks like on the test. So here's my system. How do you want to solve it? Substitution, elimination, graphing? All right, I think elimination would probably work best. So do I have a common coefficient? No. How can I create one? Multiply one or both of the equations. It looks like in this one, there's no easy way to make 3, 2, and vice versa, right? And there's no easy way to make 6, 4. So we're going to have to multiply both equations. You want to eliminate the e or the n? So if I want to eliminate e, then I need to multiply the top one by 2 and the bottom one by what?
3.
Good. Because isn't 2 times 3 the same as doing 3 times 2? So that's how we'll get a common coefficient there. Any questions about that? All right, so then multiply it out. What's 2 times 3e? 6e. 2 times 4n. And 2 times 1325. That one I can do in math. Good. All right, but otherwise you guys should all have calculators out. Don't let someone else use your calculator. You're gonna need your Chromebooks later anyway, so you might as well get them out now. All right, over here, multiply 3 by the whole equation. So 3 times 2e is good. 3 times 6n. And 3 times 17. Someone verify that. Okay, great. Now look at your new systems over here in red. Would adding or subtracting eliminate the e? Good, because they have the same sign subtract. So 6e minus 6e is 0. Don't forget to subtract everything else too. Don't just combine like terms. What's 8n minus 18n? Positive or negative? Should be negative. So negative 10n. And then 26.5 minus 51. 24.5. Someone verify that. Okay, great. Opposite of multiplying. Oh, and is this positive or negative? Remember, it was minus, right? So it should be negative. All right, and then opposite of multiplying by negative 10 is good. And what does n equal? And it's a positive 2.45. Because if it was negative, would that make sense? Can something cost a negative amount? No. So it's a positive 2.45. So if you're getting a negative, maybe look at your work again. You'll probably miss the negative somewhere. All right. And what did the n represent? Notebook paper costs, right? So if you want to write that out, this is the cost for notebook paper. So if this was like a multiple choice test and it just wanted to know the cost of the notebook paper, then I would be finished. Maybe it only wants to know the cost of the envelopes. So how would we find the cost of the envelopes? We would plug it back into one of the original equations and solve for E. That's what envelopes is, E. So which one do you want to plug it into? All right, so we have 2e plus 6, 9 equals 17. And we plug in 2.45 where n is. What is 6 times 2.45?
Super also to take the test.
Okay, anywhere that there's an empty desk. Okay, so 6 times 2.45 is. We're solving for E. I'm a little bit out of space. I'm probably going to write down here. But what do I do first? Get rid of that 14.7. Do that on each side. I get 2e equals what? 2.3. And then opposite of multiplying by 2 is dividing each side by 2. So how much does it cost for a box of envelopes? All right, so $1.15. And that matches up with what I have on my AP. All right, questions, comments? Okay, go ahead and try number 8. So this one right here, number 8, will be the you try. And I suggest, like if you're picking the variables, apples can be A, but maybe pick another variable other than oats. All right, because that looks like a 0. So maybe put oranges as X or something like that. But solve 8 next. And if you finish that one, then work on your practice while we wait for everyone else. So first, define your variables. You know, if the letters work out, great. So I would have chosen A for apple. I probably would have picked something else for orange, like maybe X, so that way I don't confuse it with a 0. All right, but they chose X and Y. And they set up their equations. 2 times the number of oranges you buy plus 7 times the number of apples you buy costs $5.36. So that makes sense the way that they set it up. You had that as your total. So it should be next to an equal sign. Same with the other equation. 8 oranges, so 8 times X, 5 apples, 5 times Y, costs $3.68. So any questions on the setup? If you think that's easy, then great. You should have no problem on your test because these look like ones on your test. Then they chose to solve it by elimination. You could have multiplied it however way you wanted, but I think the most effective would be to multiply the top one by 2 and the bottom by 3. Because 12 and 8, there's no easy way for them to become each other, but they do have a common multiple, right? So 24, I can multiply something by 12 to get 24 and something by 8 to get 24. So that's what they did. And here's our new system. Since they have the same sign on the 24x, they're both positive when you multiply them, we have to subtract them to get it to cancel. So the x cancels, and then don't forget to do it to everything else. So 14y minus 15y, negative 1. $10.72 minus $11.04, negative 0.32. Divide each side by negative 1 and 0.32 cents per what? Per apple or per orange? Per apple. All right, a good way to trick you on the test would be just to label it wrong. So maybe they say that's for the oranges, and you know it's not because we solved it, it's for the apples. Questions? All right, then plug it back in, solve for x, which represents your oranges. That should have been 26 cents. And if you really want to like double check it, make sure you're doing it right on a test, plug them in. If you do 12 times 26 cents, 7 times 32 cents, I do get $5.36. And then the other one works out all of them. So any questions? All right, you have your practice to work on for about 5 minutes, and then I'll direct you to do your exit ticket. So just start working on your practice. Remember, it's evens or odds. What else? I mean, the note sheet is great. There's tons of examples online. Like I posted the notes in school with you fully completed if you want to look at those for extra help. But I think the practice is sufficient too. So just check your answers as you go and let me know if you have questions.